Well, this is John Black, Super Chemist, Polarizer's Fundamentals, and the 3 Polarizer Paradox. Last video we watched Minute Physics and 1 Blue, 3 Brown channel talk about quantum entanglement of photons. They gave their side of their magic and their BS. So we're going to go over what they just said, but we're going to, put some logic on it. When he brought up quantum entanglement, right? He defined it as 2 photons that can be put through the same, transmission axis. We're going to pick vertical, okay? And then after that, you can rotate, you can put them to separate filters, but you rotate them at any degree, and you always get 2 checks or 2 X's, meaning they both get through or they both don't get through, okay? And you can see here I have vertical, obviously they're both going to get through, and here it's at 90 degrees, so none of them get through, okay? But if you were quantum entangled, it doesn't matter what these were set at. They could be set at 1 degree, 2, 5, 10, 100, and whatever. And always, both will come out or both will not come out, okay? Okay, this is, first of all, this is a lie, okay? You can never have that, okay? It's possible to have it, but to do it, you don't have a machine that would give you these, to have that happen. And then when it did happen, it has nothing to do with quantum entanglement, like they're buddies now forever, and whatever one does, the other one does. Because the only way you can test this to make sure that they went through every degree was to put them through every degree. And we know at 90 degrees, you know what I mean? Even if, let's say there was this fictitious thing called quantum entanglement, and you put them through, you can never prove they were quantum entangled, because sooner or later, one of them, they would get blocked by this 90-degree thing here. You know what I mean? So you would lose them before you figured you went through all 180 degrees of freedom, or you know what I mean? So they never tested this to see. This does not happen, okay? You can't have that. The only thing what they're doing is they're putting it through both of them through a vertically aligned whatever, and they call them quantum entangled. And so they have the same wave plane. The same. Their E field is oscillating in the same plane. That's all they're doing. They're not. What proof do they have they're quantumly attached? You know what I mean? This is just saying it that's what quantum entanglement means. Is meaningless if you can't prove it. And you can't prove it because you can't go through all the 180 degrees without losing the photons. Okay, so they never proved that. That's bull. Then they say, well, we take it to another planet. We put them through these 2 filters here. They're both vertically aligned, but then we separate them, distance or whatever. Okay, that's crazy too, but let's just pretend, because if we had a vertical polarizer, right, like up here, and we put some photons through it, right, we could put a board up, or, a barrier to block this off, so that the top or the left goes on one side and the bottom and the right on the other side. You know what I mean? Then we would have them separated by this, this barrier. Now this would be one planet on the bottom and another planet on the other side. Because if it works like this, then it works on, doing it planet-wide. Okay. So let's just see what they're doing here, right? They're basically putting it through. They're splitting it up with a border there, right? And then they're taking this, and they're saying that this group, because they're not taking single photons. It's not possible. This group of photons is quantum entangled to this group of photons. Then they put them through these filters, and like he's saying, they put them through, they might put them through arbitrary filters, but they have to, when they collect the data and stuff, they have to put down what degrees they are and stuff. They're basically putting it through, they're collecting the data after they get all their little check marks and X's over here, right? So they make a list. They put them through different filters or whatever. Then they take that data, right, and they figure out which ones are the same. So basically what they're doing is they're taking this top half, putting it through a 0.5 degree difference, and the same thing here. You know what I mean? And then they say, oh, This one, 85% at the top, got through. But you know what? The people that were quantumly entangled, yeah, on the bottom, 15% didn't get in. So that proves they're quantumly entangled. Are they insane? Are they insane? It doesn't. These two things, the top and the bottom, they don't care what the other one is doing. You have a group on the bottom that are all vertically aligned. That means 15% ain't going to get in and 85% are going to get through. Up here, again, you have vertically aligned, and we know if you have it 22%, 20.5, it's 85% go through and 15. These ones are connected to each other. This 15 and if 85% got through here, that means that 15% didn't. And that's the part that correlates with this, not this 15% down here. Just don't care about this people up here. Idiots. This is the same exact thing they did with the Stern-Gerlach machine and wave-particle duality. They just change everything and then they lie. Like this is a lie that, you know, these are, you can never prove they were quantumly, you can't, because you'd have to go through every degree, right? And sooner or later, you're going to get, your photons get gobbled up before you get through 180 degrees. That's a fact. Because one of them is going to be 90 degrees. 90 is in between 0 and 180. So you're going to hit it, all right? So, you know, if you want it, I'm going to show you how to get quantumly entangled. But they're not quantumly entangled, okay? It's magic, okay? Here's your E field. It's red, right? It's oscillating up and down, up and down, up and down, right? But this isn't just a lie. This is a representation. It's just a symbol. Here, the dot, the red dot or these little blue dots with the marker, that is the photon. That is what, you know, this line is this line right here, this line right here. That's nothing. It's the dot. The dot represents it. What does the E field oscillating is this dot. It's not a line. It's a dot. You know, like here's the energy. And here's the energy on this sine wave. Look, it oscillates up and down while it moves to the right. Look, up and down, up and down. See how it's not that line. It's this dot. And this dot is oscillating, oscillating. Yeah, these fields determine everything, and they're oscillating. That's why our percentages oscillate. You can see down here, right? That's why they only show you some of them. They got 180 data points they can pick from this sine wave and show you, but they only pick 3 usually. 185 and 50. That's all they ever show you, you know what I mean? But what about the rest of them? Here's 185, 50. But look, 15, 0. Then it goes back up. 15, 50, 85, 100. Then it goes back down. See how it's oscillating? But see how it gets smaller and smaller and smaller, and then it gets bigger and bigger and bigger. It's see how this is accelerating? The numbers are accelerating. If I plotted the E field and the B field oscillating, it would go exactly on. It's the same wave. If I took 100 and I made that into a distance unit instead of a percentage, like these percentages things here, yeah, I'd make a sine wave just exactly the same size as this, because that's what our probabilities are based on. This. So saying 175, 50% should be, you know, it should be like that. That's bull, because our probabilities oscillate. Why do they oscillate? Because the B field oscillates, the E field oscillates. On the photon and on the polarizer, you got four fields all oscillating. Obviously, and they all decide everything. Obviously, your probabilities are going to oscillate. What the heck? All they're doing when they do this with the two vertical, they're just making the E field go like up and down like here. But so what? See, this dot could be here on this line. It could be here. See, some of the photons that they let through, it's going to be here. Some of them it's going to be here. Some of it's going to be here. So what happens when they hit the next polarizer? See here, this one, you got, whether this is the E field or the B field, it don't matter. You got the crest hitting it. Here you got the trough. Here you got in between. And these fields determine, the torque going in here. Yeah, when you're vertical or horizontal, there's no torque. But when you go in diagonal, you get torque. We showed that. You get torque, right? So it all depends on where your B and E field is when you're going through this polarizer. That all determines your torque. The only way you can get a so-called quantum entangled, photons, okay? And they wouldn't be quantum entangled. They would act the same and go through every filter the same, no matter where you had the, transmission axis, because you lined up their fields, right? See this dot right here? Okay, like I said, that's the actual energy, and it oscillates up and down, up and down, up and down. If you got your photons, put it through a filter that got them vertically, then you had another filter, right, that took all the photons out except for the photons where they were right in the middle of their oscillation, or all of them were at the top here, okay? Then on top of that, right, because look at this, if he's in the middle here and he oscillates like this, right, when he's in the middle and he oscillates up, the B field can go two ways. It can either come out of the board or it can go the opposite way, like on the other side of the board go out, you know what I mean? Or, when it goes down here, again, it has the same, B field can come out of the thing or it can go in, behind the board. But if you lined them all up, all the E fields and the B fields, okay, so that they were all in the middle exactly the same time, right? So that, and they all went, the B field went left and right the same way all the other photons can. Then you would have the same, you can put it through any filter you want, two different filters, 0 all the way up to 180 degrees, and you will have the same outcome. Why? Because the B field and the E field, that determines everything. See, look down here. You have an E field that's red. These are all in the same plane, right? But it's not really a line, it's this dot. It's this blue dot would be the, there'd be a blue line here, right? But I just put a dot because that's the true nature of it, right? And this one, they're all coming into this filter right here, this blue right here. Yeah, but the B field is over here on this one. The B field's closer here. Now it's right on the axis of the red. Now it's on the other side. So that means if this was the filter, right, this would be the B field on the polarizer, right? And these photons are coming down, right, towards this polarizer, right? Now here, these two dots represent the energy here. This here represents this energy, This represents that, and this represents that. Why is there only one dot here? Because it's it's exactly where the red dot is. That represents the red and the blue dot. They're on the same exact spot, okay? But look at the difference here now. This one has the B field way far away from the the B field on here, whereas over here it's really close. This is the photon coming into the polarizer. This is the polarizer right here. This is the photon. It comes in, right? It can induce a current horizontally through the wire because it has enough energy, and the only reason it has enough energy is because it's totally horizontal, right? Just like the wire in the analyzer, because remember, the wire is always orthogonal to the transmission axis, right? So it induces a E field, and then that makes a B field. But look at the fields. They're together. They're parallel to each other. So they're 90 degrees out of phase, both of them. They have no torque, zero torque. The blue they're the only ones, they're the ones that get filtered, right? So look, this line represents who, after they went through. It's all blue because they all got filtered out, right? And look at this guy. So you can't, you can only jiggle vertically within an atom, because this is, when you're induce a current, not a jiggle, you're talking about jumping from atom to atom, okay? Here you're just talking about jiggling it inside the atom. You cannot induce anything diagonal. You know what I mean?